Okay, hi everyone, and welcome to this presentation showing you what is new in the latest version of Petrosys, which is version 17.3. Now the way I'm going to show you these new features is to run through a live demonstration showing you some of the key highlights of the 17.3 update. So I'm going to show you the direct display and direct gridding of Excel data into Petrosys. I'm then going to show you the surface model improvements, so you can now define your area of interest for your grid to be based on a 3D survey. We now support more stacking velocity formats, and you can use these stacking velocities as part of a workflow. I'll then show you the new mist tie reports that we have for a well tie function, and this will also give me a chance to show you the more complex filtering that we can do on lists and Petrosys. I'll then jump back into the map and show you the cartography improvements, and we'll show you the improvements to the scale bars, the north arrows, and the title blocks, and the dynamic entries that you can now have within each of these objects. I'll then show you how it's now easier and you have more options available when exporting to raster formats, as well as the support for geospatial and layered PDFs in the new 17.3. Okay, so I'm going to jump to a demonstration now. Okay, so I have here a map in Petrosys, and I also have an Excel workbook. Now if I just make this a little bit smaller so you can see both at the same time. So this Excel workbook has some well data, so it's got the well name, it's got some coordinates, and then some zone data, as well as some attribute data such as porosity and water saturation and net pay values. So it's just a standard Excel document that's been given to me, and we can just display this straight onto our Petrosys map. So if I open up the folder that this Excel document sits in, here it is here, and I just can simply click and drag that straight onto the Petrosys map. And that's it there. So now that I have my well data on my Petrosys map, I can modify this layer and do various things with the other columns present in the Excel document. So you can see here, by default, Petrosys has picked up what column it's assigned to latitude, what it's assigned to longitude, and also picked up the other columns as well, such as zone name and zone top, etc. What I can do is go into this formatter, and I can come in here and change which column is actually the latitude or which the longitude, etc. But in this case, Petrosys has picked up the latitude and longitude correctly, and it's assigned this zone top column to be the Z value. But I could come in and change my Z value to be based on porosity or water saturation, so I've got the full control over that as well. Now at the moment, this the shape type for this Excel file is reading as point data, but if this Excel document were in lines or polygons, then I could use those as well. It's just that my example has points. Now if I go into the shape tab, in here I can turn on symbols via one of the columns in the Excel document. Now in my Excel document I have a column called top pole symbol. So if I turn that on, you can see that the well status symbols change based on this column in the Excel document. On the annotation tab, again I have all the columns here that I can do what I want with them. So in this case I'm going to turn on the water saturation values. And I'm just going to make this a little bit bigger so it's easier to see. I click apply, and you can see these water saturation values are now displayed for the wells that have this data present. Now on the thematic mapping tab, thematic map is where you can assign stuff like colours based on a gradient. So if I select the series gradient option here, now it's picked up the final TD column from Excel document, and if I click show data range, you can see these values vary between sort of 1900 to just over 4000. And if I click OK to that, you can see that the colour of my wells change based on this gradient, but I could change that to be a different column or change it to a different colour gradient straight from Excel document. So that's the direct display of Excel data. If I now open up the surface modelling, I'll just quickly show you the direct gridding of Excel data. I'm just going to open up a workflow that I saved previously. Now I'll go through this workflow in a minute, but the first thing I want to do is just go into this grid creation task, and you can see that at the moment I'm creating a grid from Kingdom seismic data, but if I click on the input data tab, I can add on other data as well. And in this example, I'm going to add on some point data, and you can see that under point data, I could turn on an Excel document. So click on Excel, going away and find my Excel document, and you can see once again it's picked up the latitude and longitude columns, and it's also assigned this zone top MD to be my Z value. But I could click on that and choose one of the other columns to create my grid based on. Okay, so that's the direct display and gridding of Excel. I'm now going to move on to show you the surface modelling improvements. So this particular task I have here grids up some time data as you saw from Kingdom. It then imports some seismic stacking velocities to my SDF, converts these stacking velocities to average velocities, and then grids up the average velocity data, and that allows me to do a depth conversion based on my time grids and my average velocity grids. I've then done some well tie here to tie back my depth converted grids to my well points. And then later on in the workflow we compute some isopacks, create some volumetrics from these isopacks, and then export the results of these out to other formats. So we'll start back at the beginning then. So this is creating a time grid from Kingdom. Now under the Output Geometry tab here, in previous versions of Petrosys you could base your area of interest or the extent of your grid on a map sheet, you could base it on another grid, you could base it on the input data, or you could manually just select the coordinates that you want your grid to cover. In the new version you have this 3D seismic survey option, and as you can see here I can select a 3D seismic survey from other formats such as Betrayal or Sizeware. In this particular example I'm going to be using Kingdom. And you can see it picks up your 3D seismic survey, and when you scan it, it gives the coordinates and the cell size that are relevant for this 3D seismic survey. Okay, now another new feature of 17.3 is the ability to import stacking velocities as part of a workflow, and also we support more formats of stacking velocities. So this particular task here, if I double click on this, you can see here I've dropped in my seismic stacking velocity ASCII file, and by default it's assigned this to Western 2D format. So it's realised that the Western 2D format is the best matched format for this ASCII file. If I click on this though, you can see that in the new version we now support SOV2, we support Handbell, Promax, Shell 2D and 3D, TGS, and also the Western 2D and 3D formats, or you could create your own custom format if you would like. In this particular example, it's realised that based on the format of this ASCII file, the best match is Western 2D, but if I disagreed with this, I could simply select another format as well to use. Okay, so that's the support for more stacking velocity formats. And just below here you can see that we can also convert the stacking velocities to other velocity formats as part of a workflow, and you can see that's just from the top panel here. You've got velocities and calculate from stacking. Now in previous versions of Petrosys you could actually convert to other velocity formats, you just couldn't do it as part of a workflow, so you can do this now as part of this depth conversion and volumetrics workflow. So you have different methods here. In this particular example I'm converting to average velocities using the inverse Dix equation, but there are other methods there as well, such as interval velocity and just simply assigning stacking velocity to average velocity, and some other ones as well. Okay, so now that I've loaded in my seismic stacking velocities, I've converted them to average velocities, I could then grid up those that velocity data to give me velocity grids, and I could then do a depth conversion using our arithmetic processes. The final stage in this depth conversion would then be to tie my depth converted grid back to my original well points, and this well tie was available in previous versions of Petrosys, but what's new now is we have the ability to turn on mistie reporting. Now you could save this to a CSV file and open it in something like Excel, but in this example I'm just going to actually display the mistie report on the screen. So I'll run through this well tie, and here's my mistie report populated here. Now in this mistie report gives you your well name, it gives you stuff like the unique well identifier, the coordinates of the well, the Z value of that particular top for your well. It then gives you the untied grid value, so just the depth converted grid, what the actual Z value is at this well location. It then gives you the difference between your untied grid and your Z value before you do the depth conversion, before you do the well tie rather. It then gives you your tied grid value, so after you've done the well tie, and then the difference between your tied grid and your Z value of your well. Now this gives me the opportunity to show you the complex filtering that you can do in Petrosys now. So using the filtering option, in previous versions you could do simple filtering, such as if I turn on if I say display any well that has the letter A in it, and that's the sort of simple filtering that we used to be able to, or you still can do, but was the only available option in older versions of Petrosys. What you can now do, if I look at this difference before column, I could come in here, select a more complex filtering. So in this case I'm going to select anything that has over 100, as well as, or rather anything that has less than negative 100. Click OK to that. So you can see it's now filtered anything that has more than 100 or less than negative 100 in the difference before column. And so this is the difference between the depth converted grid, the untied depth converted grid, and my well point. So you can see here, this particular example, there's negative 252 meters of difference between the depth converted grid and my well point. So I might be thinking I might want to go back, change my depth conversion model, because quite clearly I have a big error between my actual well point and my depth converted grid. If I look at the well above here, there's over 4,000 meters of difference, and it's quite easy to see from here that the Z value of this well is in the negative realm. It's negative 2,042 meters. So quite clearly, I would want to go back to my wells, look at this particular well here, and change this Z value quickly. Something's gone wrong when I've loaded in this data. So it's using the complex filtering in conjunction with the mistie report makes it very easy to spot errors in your well tie. Okay, so that's all the surface modelling improvements I wanted to show you. If I jump back to the map now, I'm going to go through some of the cartography improvements. So this is the increased functionality with the scale bar, the north arrows, and the title blocks. So if I start with the edit scale bar option, now in previous versions of Petrosys you could modify your scale bar, but you couldn't make it quite as customized as you can now. So you can see here there's far more options available to the user. And if I click on the edit here, again you can see that you can change the fill style, you can change the line style, the intervals, the minor intervals, where you want certain numeric annotations to be posted. You basically have full control over everything for the scale bar, so you can have this looking exactly as you like. What's also now available are these green plus symbols. And anytime you see this green plus symbol, this allows you to add dynamic entries onto your object, so in this case the scale bar. So if I click on here, I could turn on the date, for example, onto the scale bar. I could put CRS information onto the scale bar. I could put the map title, the map scale. I could even put the map name, for example, onto the scale bar. In this particular example, I've chosen to put the geographic CRS onto my scale bar. As you see down here at the bottom, that's ED50. So if this particular map had to change geographic CRS, that would be updated automatically on my scale bar. So you can have the option to put these dynamic entries on there as well. And this is also present in the title blocks, and it's also present in the north arrow, as you see here. So if I modify this north arrow layer, once again you can see these green plus symbols. In this particular example I'm using the map title, so my map title gets put on this north arrow. And then your north arrows, we now have some more default looks for the north arrow, but you could also select an image if you want to use your own customized north arrow as well. Now, what you can do with this map once you're finished with it, you can export it to raster formats as you used to in previous versions of Petrosys, but we've made this easier to do now, and we've made more options available to the user when they're actually exporting it. So under File Export, you'll see this raster image option, and what you can do in here, you can change the format. So in this example I'm using a GeoTIFF, but you could use other formats as well. You can also increase or decrease the DBI or change the width or the height of this raster image. You can choose the georeferencing type, and you can choose the compression types. There's more options available to the user depending on what they're going to use this raster image for. Now also under the file export option is the ability to export to geospatial and layered PDFs. If I just turn on some of these groups here, and then I select File Export PDF, you'll see that you have the option to turn on georeference information and layers as well. So if I click OK to that, this is going to create this geospatial and layered PDF. And the advantage of these are that you can give these to people that perhaps don't know how to use Petrosys, or perhaps don't have a license for Petrosys, and they can quite easily come in, manipulate your data, turn layers on and off, and see the geographic location. So it gives them the ability to work with your map without actually knowing how to use Petrosys, or if they perhaps don't have the ability to use Petrosys. So here's my map now in PDF format, and this has just been opened using Adobe Reader. If I click on this button here, you can see that I have the ability to turn on and off entire groups, as well as individual layers that are in this particular map. Now under the edit option, I can find the geospatial location tool, and if you look down in the bottom right hand corner, you'll see that this also is aware of the latitude and longitude, so the PDFs are now geospatially aware. Okay, so thanks very much for listening to this. I'm just going to leave you with a slide that shows you some of the additional features of 17.3 that I didn't get a chance to run through. Thank you.